It's my pleasure to welcome you to the kickoff of the Hack4Rare. Thank you for coming and taking the time today. I think it's going to be very interesting with a lot of ideas and problems that are coming in. So we'll have a wonderful experience, I hope. So just some communications for today. So there are live captions available. Just click on the CC closed caption Zoom button on your bar and you'll have live captions. We have a captioner that is helping us. And also as a way to communicate, use the Zoom chat to ask questions today. So we cannot monitor both the Slack and the Zoom chat. So let's stick to the Zoom chat for today. If you have any questions, and try not to go on mute. So keep yourself muted and use the chat. We'll monitor it. We'll have multiple people looking at the chat, and we'll try to address and call you up if there is anything to be said publicly or to be communicated. We'll also, another things that I want to mention is use the Slack public channels to have a quick answer. This is in general a better way for us to avoid direct messaging. Your question definitely is going to help someone else. So use the Ask Mentors, Ask Organizers, or the Track channels to put your question in, and so that it will be public and will help others. Be ready for today. I just want you to make sure you have those 4 points. Make sure you are signed in the Hack4Rare website, that you will start filling the form for problem pitching. Created a bit.ly link, pitch H4R, for you to get there and pitch your problem. And then wait for the organizer to call you live and do your pitch in 60 seconds. So be ready. So the agenda for today, we are at the Rare Kickoff. We'll hear from Annette, president of the Children's Tumor Foundation. And then I'll move to Barb Gallagher, vice president of development. And then all of your partnering organizations today will, make a 1-minute introduction. And then we'll hear from Dachan Sun, is one of the winners of 2020 Hack4NF, a hackathon that we did last year. Is going to have some useful tips for you. And then we'll dive into how to problem pitch. A very short talk that will tell you how to create your pitch statement, problem statement, by Jessica. And then we'll also go into live problem pitching. So let's move. We have a packed agenda, a lot of times for hearing all of these problems. So let's move on. And it's my pleasure to introduce Annette Bakker, president of the Children's Tumor Foundation. I will stop sharing my screen. Annette, I think you will have a slide or more. Take it away. Thank you.
Thanks so much. Thanks, Salvo. First of all, welcome everybody. And I'm really excited to be here with you today. So I'm not going to tire you with a lot of talking, because the talking is up to you. I just wanted to introduce 1 second what the Children's Tumor Foundation is. And although this slide looks really busy, but I'm going to only focus on the 4 words. So on the one hand, we invest in research, whether that is in, I always say, competitive research or collaborative research. The other thing, what we're really focusing on is to make sure that discoveries actually lead to better treatments. And we have a whole platform that we have developed over the years, whether it's a registry, a target scan, the data hub, of course, preclinical initiatives and clinical endpoints, that is really to make sure that every discovery becomes potentially a better treatment for patients. And then we make sure that we build communities to make sure that actually everybody who can participate in accelerating this process is actually there. The NF Clinic Network, the NF Conference, of course, the patients, the regulators, the companies, and the researchers. So that is what CTF is in a nutshell. And if you want to know more, reach out to me. I'm always happy to talk to you. And of course, the Data Hub is what is the topic of the day, right? So I don't want to tire you with history, but just to give you a little bit of a background here, this data portal started very carefully in 2014 with CTF in collaboration with SAGE. And look now, NTAP, Gilbert Foundation, the NIH, CDMRP, the NF Research Initiative. So everybody is happy to incentivize their researchers to share their data. The next thing we did is, since data sharing is not enough, data sharing and data usage is really something fun. So we did the very first hackathon in 2019 in San Francisco, 2020, last year, virtually, again, always focused on NF. Then we made connections with the Life Science Nation to make sure that our ideators can actually get in front of investors so that there is real money to be received for the projects. And look where we are today. Today, we've expanded our family, MIT, P10, Rhizopathies, Research for the People. So needless to say that I'm extremely excited about this. And I just want to thank two people who have been the real drivers of this whole show, is Barb Gallagher and Salvo Rosa. So with that, take it away, Salvo.
Yes, thank you, Annette. Thank you so much. So the next person is my partner, Barbara Gallagher, VP of Development at the Children's Tumor Foundation. So, Barb.
You're on mute, Barb.
Hi, everyone. Great to have you all here today. We're just so excited to launch this year's Hack4Rare. And in addition to the support of all the partners you're going to hear from, we really want to give a special shout out and thanks to our sponsors and data partners without whom this event would not be possible. Really want to welcome back NTAP and Gilbert Family Foundation, Wuji AppTech, Salesforce, Helix, and AstraZeneca partnering with us again this year. And we're excited to welcome Charles River Laboratories as a new partner this year. And again, as Annette mentioned before, we're really appreciative of Sage Bionetworks. We are going to be using their Synapse platform this year for the hackathon, and they've been a fantastic partner. And as you can see, we have numerous data partners here, some new, some returning, and of course, our community partners have been really helpful with recruiting people for the hackathon. So thank all of you for all you're doing to help support this event. And now I'm going to turn it over to our co-hosts, Julia from MIT Hacking Medicine.
Thank you, Barb. Hi, everyone. I'm Julia from MIT HackMed. As you already heard from the hackathon intro webinar on Monday, our mission is to democratize healthcare innovation. And we do this by organizing healthcare hackathons, working with partners all over the world. We're really excited to have had this opportunity to partner with the Children's Tumor Foundation and everyone else to bring Hack4Rare to you. Throughout the hackathon, our HackMed team will be working with you all through our programming, such as the pulse checks, practice pitching, and how to pitch presentation to bring our experiences and support and help all of you succeed. We highly, highly recommend that you all attend these events, as historically, most successful teams have been very diligent about that. If you have any questions for us, feel free to ask in the Ask Organizers channel and tag us with the keywords MIT Organizers. We're really, really excited to see the collaboration and solutions that you all come up with over these next 5 weeks. And now I'll hand it off to Robert with Sage.
Thanks. Hey, everyone. I'm Robert Alloway from Sage Bionetworks. I'm one of the few people on the Sage team who are helping support this hackathon. I just wanted to give you a brief introduction to what Sage is and what our involvement in the hackathon is. So we're a nonprofit research institute. We're based out of Seattle, Washington. And our general mission is to use open practices to speed the translation of science to medicine. And so our expertise, and this is not speaking for myself, but Sage more broadly, is within building data sharing tools, coming up with strategies for data sharing, working on data governance, developing mobile health apps, and then performing computational biology research, as well as community-driven research projects such as hackathons and challenges. We build two platforms that are going to be used pretty heavily in this hackathon, both Synapse and the NF Data Portal. So if you have any questions about how to use those or to navigate them or to access any of the data that we're working on sharing in this hackathon, please don't hesitate to reach out on Slack. And I also just wanted to plug our open positions page. We have several open positions in digital health, software engineering, data governance, and computational oncology. And please don't hesitate to check those out and reach out to me if you have any questions about those. Just finally, we're also providing support for this hackathon in terms of Amazon Compute. So we have a small budget to provide cloud computing instances to people who might need them. If you have any questions about using those, we have put together a guide on the hackathon page that you can read, but please, again, don't hesitate to reach out if you have any questions about how you can best utilize those resources. And with that, I think we're moving on to the next partner. Thanks, everyone.
Thank you, Robert. And here is the round of the introduction of the different tracks. So the first one is neurofibromatosis. It is run and sponsored by the Children's Tumor Foundation. I'm Salvo La Rosa. I am the Chief Scientific Officer for the Children's Tumor Foundation. What I want to thank is our patient mentors that are willing and splendid to participate into this year, but also some of them returning from last year with a wonderful experience. So thank you to all of them. Thank you also to the expert mentors, Nancy Ratner, David Scotchell, and Thomas Dorat. We'll also have others that will join later. And our co-organizer, of course, Barb and Leah, our CTF intern that is helping us behind the scenes and will also help all of you to get scheduled meetings and stuff like that. So please check on our track, check all of the material that we share, check all our data. There's pretty much a lot there. And reach out to me for any question related to NF or the general hackathon. So next to them, P10 hamartoma, Christine. I'm not sure if Christine is here. So in the
I don't know if she's here, but this is Tom Frazier. I could maybe step in quickly.
Oh yeah, Tom, please.
Yeah, so I'm not sure Kristen's able to make it, but P10 hamartoma tumor syndrome, or PHTS for short. So if you hear that, that's what we mean. P10 is an underdiagnosed genetic condition. It's associated with both inherited cancer syndromes and benign growths, but also with neurodevelopmental issues, including a spectrum of neurodevelopmental problems, all the way from fairly mild problems with working memory, processing speed, executive functioning, all the way down to more significant problems like intellectual disability, autism, and other neurodevelopmental disorders. P10 is a tumor suppressor, and it's also really important for brain growth, including the growth of white matter, as well as neural cell growth and dendritic projection. So it's a low prevalence, at least as best as we know right now. But we're developing as a rare disease group, we're developing quickly. And the P10 hamartoma tumor syndrome foundation has been a big part of that growth in terms of improving care coordination and helping to share data. So I'm part of the team of clinician mentors and just really excited to be a part of this, this hackathon.
Thank you, Tom. And let's move to track 3, RASopathies.
Hi, my name is Beth Stronach. I'm the board secretary for RASopathies Network, as well as a parent of a child with Noonan syndrome, which is one of the RASopathies. Our organization tries to facilitate collaboration and research to serve our RASopathies community and lead to treatments to improve the quality of life for children and adults with RASopathies. And so, as you've probably heard already, the RASopathies are really a group of neurodevelopmental genetic syndromes that all relate to upregulation or dysregulation of the RAS MAPK signaling pathway. And so we're providing, or track 3 basically is to try to come up with solutions for problems that RASopathies families face. We have a group of awesome mentors. Pau Castell is a researcher at UCSF. Betsy Rosenbaum, Tuesday Dyer, Brent Dyer, and Les Rogers are affiliated with CFC International. And they are parents of children that have cardiofaciocutaneous syndrome. Lisa Scheuer is the president of RASopathies Network, and she has a child that had Costello syndrome, and Colin Stone also represents Costello syndrome, the International Costello Syndrome Support Group. So all of these people are willing to help you out, help you think about problems and solutions. So thanks to the sponsors and thanks to CTF for allowing us to partner.
Thank you, Beth. And we'll move to the collaborative track, the desmoid tumor patient case. I'm not sure if Peter or Vanessa are here. I will just give you an update that the track is almost on hold now on this collaborative track. Is not, so this track is more like a all hands on deck collaborations to solve Vanessa's case that is a suspect desmoid tumor but not confirmed. So the team is still collecting data. So more updates will be available in the next few weeks. And research to the people is still waiting for new sequencing data that will come from Memorial Sloan Kettering. So stay tuned as this data will be available. There will be more development for this collaborative track. Okay. And then on top of all of the specific mentors that were mentioned during the different tracks, I just want to mention also all tracks expert mentors, Hallie Hawkins, Alex Joyner, Nikesh Kotecha, and Jesslyn Taroni. You can reach out to them. They're experts in computational biology, but also many other sectors. So reach out to them. You'll find their profile and all of the mentors' profile on the Mentors tab. And welcome to our initial list of judges that will be here to listen and to judge and score your file submission on July 30th. So come back because we have more mentors and more judges that will be announced soon. So if you need expertise, just browse them and ask for help on the Slack channel. So now I would like to introduce Dao-Chan Sun, assistant professor at Medical College of Wisconsin. Dao-Chan was one of the winners of 2020 Hack4Rare. He couldn't be here today, but he sent us a recording of his presentation. So I'm going to pull this now and play it for you.
Hello, everyone. My name is Dao-Chan Sun. I'm the last year's AF1 Hackathon awardee on the drug screen challenge. Thanks to the organizer to give me this chance to share the experience and my tips with you guys. I have been working on the AF1 field for more than 10 years. Starting from 2015, I work as a research associate at the Memorial Sloan Kettering Cancer Center. I use mouse models to resemble the AF1 associated tumors. At the same time, I like to do the biological big data analysis, make use of all this kind of omics data to reveal some insights of this disease or generate new hypotheses. A couple months ago, I found a position as assistant professor at the Medical College of Wisconsin. And now I have my own lab to work on this AF1 associated tumors. Last year, I got to know the AF Hackathon event through the CTF email. Once I see this, I make a decision to join this event right away. Because for rare disease, there is rare resource and a rare data set. And this event has very well curated research data. And at the same time, find good drug target is also among my research aims. And the most important, actually, I don't want to get isolated from the lab. I want to meet the patients, talk with the expert, and communicate with the F1 community. So this is really important to keep my passion going on and get myself inspired. When you decide to join this fantastic event like me, the next question is where to start. My suggestion is play, check, and think. You'd better to play with R or Python code provided by the organizer and try to understand the structure of the data. Also, at the same time, please check the previous AF1 hackathon project. And you also can borrow some ideas from different hackathons or toolkits and that can be used in this one. And also be aware of the publicly available resources. And then think about the pinpoint in the research, clinics, and patients' everyday life. Just try to create the smallest and easiest prototype function, and then think about getting an efficient team. I can use my project as an example. I found many common pinpoints in the drug screen. Before the drug screen, patients and clinicians may feel they have few choice for the treatment, but after the drug screen uses thousands of small chemicals, they may suddenly realize there is too many choices. What they really want is the best one, or at least a top-ranked candidates. At the same time, we have to keep in mind that the cell line-based drug screen has a different tumor physiological environment, which indicates the candidate who works on the cell line may not necessarily work on the mouse model and in the human patients in the clinical trial. Among the candidates, they may have some novel chemicals. We have very few information about that. Can you help the clinician or scientist to know the mechanism and the targets? And another thing, as I mentioned, a ranked candidate list will help the researcher and the clinician to prioritize the limited resource for the downstream verification, which is very important. This is the flowchart of my project. I first download the transcriptome data of the cell line used in the drug screen. And I also download the primary tumor tissue transcriptome data from other research. So I found the conserved gene regulation network, which indicate this consistent between these two model systems. I use the gene ontology analysis to annotate the genes within each regulation network to identify the enriched geo terms. On the other hand, I just also download the drug response data, and the area under the curve indicate how well the drug work on the cell lines. I calculate the correlation between the AOC and the conserved gene regulation network, and based on that correlation to subgroup all the drugs into different group. Since this drug library is a well annotated small drug library with 2,000 chemicals, we know most of the drug target. So I use those drug targets to do a similar gene ontology analysis. And later I will calculate the similarity between the conserved regulation gene network and the drug groups. The rationale is if the gene ontology terms are very similar, that means these drugs are really targeting the gene regulation network you are expecting they are. So this will give us a ranked candidate with a biological relevance. When you have your project in mind, you can start to build your team, or even before that. My recommendation is at least include one professional or one patient in your team so they can provide feedbacks in time. Teamwork is essential, and everyone in our team should have clear rule. I'm the project leaders and in charge of most of coding work. And I have a neuro-oncologist and a pediatrics oncologist on board. All of us works in the Memorial Sloan Kettering at that time, which help us to communicate very easily. Finished most of the work within 10 days spare time, and then completely get distracted because the whole hackathon is about 1 month long. And I start to wrap up in the last 2 days when I get a reminder from the Slack channel. So I just rush to submit through the GitHub and a Docker container. But it's first time for me to work with dog container. So it seems I'm trying to make it work even at the last minute. Last but not the least, this event has a very good mentor mechanism. Make sure you talk with the patients, professionals, or researchers. They are so helpful. And also remember to keep communication via Slack channels, ask questions, answer other people's questions if you can. And you can always ask Janita and Salvo. They are so helpful. And also keep in mind, through this event, we can make new friends and try to learn from each other and the community. So ending this rare disease, we need the joint force of everyone. So I just hope everyone will have a unique journey of their own in this hackathon event. And Slack me if you have any questions. Thank you.
Okay, thank you. Ciao. Thank you so much. I think this was useful for all you. He had a great experience, and his project actually was also presented as a poster at the 2021 NF conference that actually happened last week. So it's my pleasure now to introduce you to Jessica Zhu from MIT Hacking Medicine. We'll basically dive now into the process of problem pitching and how to problem pitch before we open our live version. So take it away, Jessica.
Thank you, Salvo. So as I pull up sharing screen, I'm actually going to run over a quick summary of how to problem pitch in case you missed the presentation on Monday. If you did watch it, and this is just a repeat for you, I'd encourage you to think about a problem you want to submit, and you can go ahead and submit it right now in the form. If another person can drop the link in the chat, that would be great. Okay. So yeah, as my teammate Julia mentioned earlier, we at Hacking Medicine are excited to bring parts of our process to you at this event. And one of those processes is problem pitching. So we definitely really encourage you to pitch a problem. It'll help you form a diverse team. It can help you recruit additional teammates if you already have a set. And you can also have a chance to discuss about your problem that you pitch with other people on a specific Slack channel that we'll create just for you. In order to pitch, you'll want to sign up on Synapse, and the link, thank you, Michael, was just dropped in the chat. If you can't pitch today or you think of another problem later, you'll have 2 more opportunities to also make a pitch. But we definitely encourage you to try to do it today as more people are able to attend the kickoff today. So to review what a well-defined problem statement is. A well-defined problem statement for us is a clear and concise statement that describes the symptoms or the pain point of the problem to be addressed in quantifiable terms. It enables people to readily grasp and understand what you're trying to accomplish. This also serves as a great communication tool, helping to get buy-in and support from others, which are your fellow participants in this event. A good way to think about your problem is asking the 5 W's. So for who does it affect and who are the customers? What is the actual problem? What is the impact or consequence? What happens if it's fixed or not fixed? What are the shortcomings of any current approaches or similar approaches to solving this problem? For when does it occur, and what is the urgency of it being fixed? Where does the problem occur, or why is it important to fix the problem? So we encourage you to think about all of these questions through the lens of each stakeholder that is affected by your problem. Some key stakeholders you might face are patients, providers, payers, pharma or industry, or the patient's circle of trust, which is their family or caregivers, for example. So a few more suggestions we have for a successful problem pitch is to try to be quantitative if you can. It can also be helpful to pick a specific customer or end user. It's okay if you end up switching who that person is, but it helps to pick a specific person now so you can start going through the design thinking process with other participants after this session. It's also really helpful to build a persona. So if you personally know someone who is facing this problem, you can talk about them. Or if you know generally where this happens, you can also say, like, talk about a composite of people who are affected by this. So some examples in general would be a 52-year-old female recently diagnosed with something, or a large academic medical center in Boston. Or you can talk about family members of patients suffering from something. So those are all great ways to make your problem statement more specific. Also, don't confuse your end user and your economic buyer, especially within the healthcare space. These groups are often different. For an example of what a good problem statement would be like, it's great, like I said, to tell a story. So an example would be, my father is blind and can't tell apart his meds because all of his pill bottles are smooth and similar in size and shape. As a result, he is dependent on me or another family member sorting his medications into containers marked with Braille every time he gets a refill. An example of something that's not a problem pitch is, I want to build an app that analyzes mood and vital sign data. You can see this statement starts out with building an app, which is a solution, not a problem. And saying this would narrow down the possible scope of solutions that other people in your potential future team might think of. So I know that might have been a lot really fast, but just remember, keep it to 60 seconds, be as specific as you can, and don't talk about solutions. If you submitted something previously and you realize, oh, I think I wrote about a solution in that form, that's okay. If you want more time to think about it, when we call on you, you can just say pass and we'll come back to you. So how it'll work is, make sure you sign up on Synapse via the link that Michael sent in the chat to do a live pitching slot. Here's the link again. I will call on the two people up next, so you're ready. You want to raise your hand in Zoom, so this will bring your profile to the top of the page and make it easy for us to find you. And when it's your turn, you can unmute yourself and we'll time a 60-second pitch. After you're done, please go back on mute and remove your raised hand and enjoy listening to everyone else's problem pitches. If you think of more than one pitch, you can definitely submit the form more than once. Just make sure each submission is just one problem pitch. All right, so right before we get started, does anyone have any quick questions about the process? Okay, I guess another reminder for clarity, at the end of your 60 seconds, you'll hear the timer the timer from one of our Hacking Medicine team members will go off, so you'll hear that. If you have questions on pitches, Chip, can you clarify, do you mean like you want to ask the person who pitched a clarifying question or follow-up question?
Yeah, it could be follow-up question. I think it's okay for the people who is pitching to answer later on, but it would just be great to follow up on a specific question. So is there a proper channel for us to post on these questions?
Yeah, so I think to keep everyone's focus on all the great pitches that are happening live, I would suggest you just jot down your questions for now. And after the entire session is over, there will be a bunch of Slack channels that open up, that each channel is identified by their pitch number. So as you can see, like, you'll see the number on the screen for who's going. So you can write down, number 2, I have a question like this. And you can message it in the pitch _002 channel later on. We'll cover this again after the end of pitching. But yeah, just hang on tight to your questions so we can keep the Zoom chat open and also people focused on the Zoom, not the Slack.
Sounds good. Thanks, Jess. Appreciate it.
All right. So without further ado, we'll get started here. Okay. So first up, we actually have a submission from Salvo. So feel free to unmute. And after Salvo, we'll have Yuri Kim.
Yes. Okay, great. Tell me when my 6 seconds start.
Oh, just whenever you're ready.
Okay, so I think NF specialists can easily recognize cutaneous neurofibromas and dermatology phenotypes in patients. It's because they see a lot of patients, and of course, they are in an expert clinic. The problem I see is with non-specialist doctor that and family physicians that struggle to recognize maybe cutaneous neurofibromas or other features that are visible. And those patients, they end up with a delayed diagnosis or maybe misdiagnosed. So that basically will not help them to get to the care they need. So I think this is a problem, especially in diagnosis, but also how can we help these patients and these physicians to understand a little bit more this problem.
Thank you, Salvo. And so also if you submit multiple problem pitches, I might just give like a little teaser so you know which one we're calling you up for. So Yuri Kim is up next. And this is regarding your pitch description starting with children diagnosed with NF1. And on deck will be Kristen Anthony.
All right, thank you. So the problem that I want to pitch has to do with optic pathway glioma patients. So about 20% of NF1 patients develop tumors along their visual system, and these are called optic pathway gliomas, or OPG for short. And these children require regular monitoring of their tumors and their vision, particularly early in their diagnosis period. However, they are not typically seen by clinicians more than every 6 to 12 months. So vision loss, which prompts treatment oftentimes, is unpredictable and can happen in between these clinic visits. So a method to monitor visual function in these children, particularly between these clinical visits, could really help detect visual decline sooner and hopefully prompt earlier treatment as necessary.
Awesome, thank you. All right, so number 3 is Kristen, and on deck is Andrea. Also, apologies in advance if I mispronounce your name. I'm sorry. All right, whenever you're ready.
Hi, can you see me?
Yes, we hear you.
Fantastic. In our community, there is data readily available, but that data is siloed. We are looking for solutions to allow for a patient-facing mobile home or mobile medical home where they can share data with our patient registry, but they can also share secure data with their clinicians and research teams.
All right, thank you so much. Okay, number 4 is Andrea, and on deck is Kapil.
Hi, I'm Andrea Albashir. I wrote this as a persona of a sort of a general parent of an NF1 baby. So I'm an expectant mother. Prenatal testing shows my baby has NF type 1. I know that type, severity, and progression of NF1 symptoms can vary greatly between individuals, even in the same family. I want to do everything I can pre and postnatally to reduce my child's risk of severe symptoms. The doctors tell me to just watch and wait for symptoms to occur, but I feel that it's my responsibility as a parent to be proactive. There are many suggestions in online blogs and social media sites for specific diets, vitamins, and other supplements that might reduce the risk of symptoms, but I don't know what information can be trusted. Can someone give me a science-based proactive strategy for raising a child with NF1 so I can feel confident that I'm giving my child the best possible start?
Thank you. All right, number 5 is Kapil, and on deck is Salvo.
Hello everyone, my name is Kapil Dev Nair and I'm a clinician from India who has particular interest in machine learning. During my pediatric rotation, one such case really resonated with me where I saw a 5-year-old child with macrocephaly, intellectual disability, and no money to even confirm that he has PHTS. In his life and diagnosis will forever be a question mark to him. In this new age of machine learning, I believe it is possible to provide a better insight into the progression of the disease, provided we have enough high quality longitudinal data to train smart models on. This has been a particular issue because as of now, the only way to get longitudinal data is for patients to keep coming back to their physician, which is a cumbersome and time consuming process for the patient. Thus, they're much less likely to comply to the collection of this data. Longitudinal data is necessary because with longitudinal data set, which has a relevant clinical information and correlating genetic data, we can actually start accurately predicting how this disease will transform over the years based on the genetic makeup of the patient. As a clinician, I can help build the inpatient part of this project, but I will need your help, specialists from various disciplines like bioinformatics, biotechnology, and other fields to make this project a reality. I implore you.
Okay, unfortunately, that is 60 seconds. We want to keep it fair for everyone. But if you have like a separate problem pitch you want to pitch, you can definitely submit the form again. Thank you. All right, so Salvo is number 6, and on deck we have Yuri Kim. Yeah. And for Yuri, that's your pitch about loss or reduction in functional neurofibromin protein.
Okay, that's my second pitch. Patients, when they are newly diagnosed, they turn into internet to find information about their disease. The problem is that the internet is overwhelming with a lot of info and often is not relevant. It's just, the most frequently visited website or, manifestations. So that information and that experience is not relevant to that specific patient. And this really applies to all rare disease patients. It's easy to find information about breast cancers and large cancer that affect large population, but for rare disease, it's difficult to dive into the specific of that patient. How can we help patients find the results and avoid the frustration of not finding the right answers? And there is a lot of information that can be used, but difficult to track.
Thank you, Salvo. So up next is Yuri Kim, and also on deck is also Yuri Kim for your problem pitch about the lack of a scalable method to identify. I think you know the rest of what I'm saying. So.
Hi, I'm Jim Goss. I work with Yuri, so I'll be presenting the next problem. Awesome. So NF1 is a disease which is characterized by a loss of the neurofibromatosis protein and its function. And so many therapies are designed to increase neurofibromatosis in cells and tissues and increase the function. What is needed are both sensitive, reliable, reproducible methods to measure and quantify neurofibromatosis and neurofibromatosis function in order to evaluate different types of therapies.
Thank you. All right, and number 8 is your third problem pitch, and then on deck is Manasi.
Hi, this is Kalyan Manakoda. I work with Yuri Kim. This problem starts with NF1 patients with optic pathway gliomas. About 20% of children with NF1 develop optic pathway gliomas, and half of those with optic pathway gliomas will have irreversible vision loss. One strategy for restoring vision in these patients is to transplant stem cell derived retinal ganglion cells. So researchers are developing new retinal ganglion cells from stem cells in the hopes of being able to transplant these cells in the eyes of blind and OPG patients. But at present, there is a lack of automated scalable method to identify transplantable differentiated ganglion cells from culture, various types. So a solution to this problem would greatly enhance the success of being able to purify these cells at scale and potentially advance transplantation therapies.
All right, thank you so much. So far we've had 8 awesome problem pitches, and thank you to everyone else who's also been submitting. So definitely keep those submissions coming, and also just a reminder to make sure that your pitch is about a problem and not a solution. The ones so far have been really great, so keep that up. And also, if it's a problem that you think should be solved, but you personally might not want to work on it, or you think you're not the best person to work on it, feel free to give that pitch anyways. A team can form without you in it. And so just the more problems we have identified on the table, the better. So yeah, if Michael, you could drop the link in the chat again for everyone in case people have lost it. All right, I'm gonna give a second for everyone to have a second to think if you have more problems. All right, thank you, Michael, for dropping the link in the chat. All right, okay, I think we can keep going for now. All right, number 9 is Manasi for your pitch on, sorry, I lost my mouse. Your pitch, oops. Your pitch on when people don't have access to quality healthcare, and on deck is Dana.
Hi, can you hear me? I'm sorry,
Yeah.
there's some problem with my camera. Can I just go on without the video?
Yeah, no problem. We can hear you.
Okay. So, so especially in like remote areas and people and places with limited access to healthcare, especially in countries in third world countries where a lot of diseases are already rampant, so that the government and the private establishments cannot pay as much attention to these rare diseases. Parents with kids who have these diseases can find it very difficult to access reliable information and to get in touch with support groups of similar parents facing the similar problems. And also they have very limited access to specialists. So as I believe that healthcare should be universal and should not be limited to your earning capabilities or in what place you live. So I believe that there should be a solution to this, so that the parents from poor countries or from resource limited areas can also get their kids the same level of healthcare as in first world countries.
All right, thank you so much. Number 10 is Dana, and on deck is Manasi again for your problem pitch about getting access to healthcare early.
Right, thanks. So my pitch is on the problem of lack of scheduling services available for rare diseases, and how difficult it is to actually find facilities as part of your treatment plan to actually get help. And that's even more exacerbated in areas that have lack of access to services and healthcare plans. That's it. Thank you.
Thank you. All right, number 11 for Manasi, and on deck is Kristen. Manasi, are you there? can come back to you if you're having a problem with your mic. So let's go to number 12, Kristen, and on deck is Thomas.
Hi, this is Kristen with P10 Foundation. To our point before about siloed data and coming up with solutions to break down the barriers with siloed data, we are also looking for applications that can effectively integrate with patient registries and clinical registries that are patient facing. Thank you.
Thank you. All right, just checking, Vanessa, are you ready to pitch yours? Or we can, all right. Oh.
Hello.
Hi.
Yeah.
Got your camera working. All right.
Yeah.
I'm gonna go back to number 11 for you.
So another problem that we face, especially neurofibromatosis 1. So there are plexiform neurofibromas, which have the highest potential for turning into malignant neurofibrosarcomas. And there's a 5% chance in the lifetime of a person that he or she will develop these malignant tumors. So what another problem is diagnosing these problems early. So, I mean, these can take forms of optic gliomas or peripheral nerve sheath tumors, which can be quite painful also. And these also, I mean, it's rare, but it has been noted to cause lung problems and interstitial lung diseases also associated with carcinoma syndromes and tumor syndromes. So there could be a way to diagnose these malignant changes earlier on so that they can be managed effectively and so that the morbidity and mortality can be reduced in these scenarios. Thank you.
Thank you. All right, I'm gonna skip over 12 because we just had Kristen do that. Number 13 is Thomas, and on deck is Lisa.
Is this Tom Frazier that you have as Thomas?
Yes, yeah, I see Thomas Frazier, yes.
He had to jump off for a meeting. However, he said that he would be able to pitch this at the next opportunity. So be looking for that.
Okay, awesome. Thank you for letting us know. All right, so number 13 will actually be Lisa, and then on deck is Adam.
Hi, so just diving in, our families struggle not only, this is the restopathies, our families struggle not only to manage the medical and developmental issues generated from the syndromes, but also to manage the services provided to address them, as well as the payers. My son had over 20 specialist medical professionals, occupational therapists, physical therapists, speech therapists, vision therapists, and 9 case managers. And then there's special education, which is complex to avoid manipulation from the school districts with their own challenges, which are not supposed to spill into our families. And also the myriad bills from the various providers, despite being covered by one of 3 insurance coverages in our situation. Many of, and being sent to collections on several, typically from one of the hospitals, actually. So struggling against that type of stuff. Many of us parents share that our children have trouble sleeping through the night. So we're doing this with extended sleep deprivation too. Help.
Awesome, thank you, Lisa. Next up is Adam, and on deck is Beth.
So for better or for worse, Lisa just touched on a lot of what I wanted to say. But as a patient with neurofibromatosis type 2, I see a lot of specialists, especially therapists. I see a physical therapist, I see an occupational therapist, I see a speech therapist, I see a therapist for my head, and there's lots of therapies to work on. The problem is it's really hard to prioritize these. Right now, I have about 25 or 30 pages of therapies sitting next to me on my desk. And I have no idea which ones are the most important or how often. I think it would be great to coordinate this with a doctor, like a physiatrist, So I know which therapies to do and how often I should do them. So it's not as overwhelming to my personal life.
Thank you, Adam, for sharing. All right, number 15 is Beth, and on deck is Robert.
Hi, this is the Rhasopathies track. I've been diagnosed with Noonan syndrome, but the molecular mutation is more consistent with cardiofaciocutaneous syndrome. How do I find out or confirm my diagnosis or get the right information so that I can anticipate the problems that I might have? One thing about the Rhasopathies is that it's many syndromes caused by many mutations in 20 to 25 different genes. So how can we untangle that that pathway? Thanks.
Thank you, Beth. Number 16 is Robert, and on deck is Debbie.
Cool. Thanks so much. So this is a problem we face on a day-to-day basis at Sage. Machine learning has promising applications in the study of human disease, but in particular, rare disease data sets are challenging to analyze using machine learning because these diseases have varying symptoms, and there's often not enough training data to create generalizable electronic health records, genomics, or imaging machine learning models. So any new strategies or machine learning methods that can overcome or be less impacted by these limitations would be of a huge value to rare disease researchers.
Thank you, Robert. And next, number 17, we have Debbie. On deck is Tuesday Dyer.
Hello.
Yes, we can hear you.
Devi Krishna, who's on deck?
You're up. You're going right now.
Okay, yeah. So I'm Devi Krishna, and my problem pitch is regarding Rhasopathies and the webinar which I attended. So the main problem which I found was lack in communication between a patient and therapist, or a lack of communication or understanding, because of which I've read in some papers causes a lot of anxiety and a lot of issues with diagnosis. So so I would like to problem pitch this particular issue with some strategies we can come up using image recognition or machine learning. Thank you.
Thank you. All right, number 18 is Tuesday Dyer, and on deck is Salvo.
Hello, all. The issue that I would like to pitch is pain management and CFC syndrome. We hear anecdotally from our parents that pain management is very difficult to predict, and it's also hard to determine what level of pain our children are experiencing because of significant communication variations. Many of our individuals with CFC syndrome lack verbal skills or good communication structures. This anecdotally has been shared with us as being an issue for sleep and potential sleep disorders. One mom expressing to me that oftentimes they do not know if their child is in pain until, or has an ear infection and is experiencing pain from the ear infection until they actually see blood from the ear of their child. So our pitch is to find better communication structures for individuals with CFC syndrome that are experiencing pain.
Thank you. All right, number 19, we have Salvo.
Hi, it's me again. So I think there is a large variability of manifestations in NF1 and F2, but also in other rare diseases. Even among patients that share the same genetic mutations, there is high variability of manifestation and symptoms that they develop. How can we identify genetic modifiers of major clinical features? Like some patients may experience strong pain or severe form of autism or learning disabilities, and this is totally unpredictable. What are those genetic modifiers and that characterize those factors, and how can we identify them?
Thank you, Salvo. So we actually don't have any more submissions, and I know we just covered a lot. So I'm actually going to take a few minutes to give everyone a little bit of a breather, maybe digest what you've been hearing, think about if you have any other problems you want to pitch to everyone. And Michael will drop the link in the chat again for your reference. Lars, regarding your message, we don't see your submission. Would you mind submitting it again? All right, I'll answer the next two questions verbally. So Debbie, your question, if our problem pitches are similar to other ones, can we integrate teams? Yes, definitely. You'll still have two separate pitch channels on Slack, but you can definitely integrate when you do team formation. If the opposite happens, where a lot of people are interested in one pitch, you can decide to split up into smaller teams. And we definitely encourage that because the two parallel teams can approach the problem in slightly different ways. And then for Martin, your question, this will be posted as a recording. Yes, definitely. We know this goes by really fast, so you'll get a recording on Synapse, and you will also see a cleaned up table of all the pitches of the numbers and who presented them, as well as like a very short summary. So that should be all helpful for you all to reference which ones you've heard. All right, I see some more submissions coming in. I think it would be great. Can we get to 25? I think it's always helpful to have just the number or have a wide variety of problems identified, even though maybe not all of them might be worked on. So even if you have a problem where you think like, I have no idea how you solve this, I don't even know if we can do this during the hackathon, I'd encourage you to still submit it anyways. You never know what people might come up with. We have such a diverse group of participants here. All right, Michael just dropped the link in the chat again. And just so that we make sure everything's in the recording and also you make it onto the table, we'd encourage you to please use the form instead of the chat or raising your hand separately. All right, I think it's a solid amount of break. So number 20, we'll have Lisa. And on deck, we have Annette.
Okay, so again, for restopathies, patient registries are valuable to build a database for researchers, but it's not easy for families to answer questions when they're prompted. Instead, I see trends of families asking each other about various issues, including problem solving between them, what our child's doctor did, what meds they're on, of course, not to be taken as a prescription, but to go back and ask their doctors. These get shared among them, but not those who don't plug into the network when those discussions are being made. In the past, I was able to notice conversation patterns and share with our researchers, like a bunch of moms talking about carry-1 malformations, seizures, false positives from the urine test screening for neuroblastoma, all of which were forwarded to the researchers, and they were great. They worked on it and published, but there was about a 3 to 5 year lag. And so I wonder, how can we help families faster? Thank you.
Thank you, Lisa. All right, number 21, we'll have Annette, please.
Hey, this is super cool, first of all. So what I wanted to pitch is that, and Robert and Solvable recognize me here, is that we have a lot of data that is entered by data scientists. And the only one who can really go interrogate that data are, again, these data experts, right? So my dream would be that we really can get citizen scientists involved. And how can we make that happen? How can we make the data more accessible to people that don't per se have a PhD in computer science?
Thank you, Annette. I also noticed you sent something in the chat. Was that a second problem you wanted to pitch?
Yes, because I'm too stupid to be able to get into that form. So the second,
We'll let it slide. We'll let it slide. We can manually fill you in for this one. So yeah, number 22.
Yeah, Jessica, I'm filling in for Annette. Annette, you'll be called.
That's why we need citizen scientists, right? So okay. So the next pitch that I wanted to throw out there is that we're always talking about very rare diseases, or people lump them together, and then suddenly we're millions of people, and there's this 7,000 rare diseases with this huge variability of manifestations. And some have manifestations like, for example, epilepsy, which we see across a number of rare diseases. And what I would love to start to understand is how can we start working across rare diseases and kind of understand from each other's data sets and focus maybe sometimes on symptoms rather than just on the biological pathways.
Thank you. Salva, did you have something to say too? Or?
No, I was saying that I'm typing in for Annette this last pitch.
Okay, thank you. Okay, and then I believe
I can throw in one more.
Oh, okay, awesome. Let me switch
so
to
we are getting more and more interested in pain, and I heard somebody else talk about pain. But one of the main challenges that we have with pain these days is the subjectivity of the outcomes for pain. Pain for one person is much earlier than somebody else. And what I would love is to see, would there be objective measures, objective pain measures? I think that would help the field forward so much.
Thank you. All right, number 24, if Lars Eriksson, if you're still in the Zoom, I know you couldn't access the form, so okay. If you want to just, verbally say what you're thinking.
All right, am I coming through okay?
Yes, we hear you.
Okay. Last year in the hackathon, there was a guy named Bill Ritter. I think he's listed as a mentor this year. He has MRIs and readings. And one topic is to machine read MRIs, but the goal of that would be to match the physician reading. The physician reading is a block of text. So the idea that people could work on is an ontology for NF-MRIs, which allows you to encode in a canonical way into a JSON or whatever the content of the reading, so that you could then, if you were to write a machine reading program to machine read an MRI, it could generate the same format, and then you could compare and score the difference between the human reading and the MRI. So the problem is generally MRI ontology.
All right, thank you, Lars. So 25, we can see a submission from Beth.
Just a sec. Okay. So many of the oncology drugs or the cancer drugs that are being developed and designed actually target KRAS, which is one of the RAS isoforms or RAS genes. So what other protein targets might help the RASopathies where the patients don't have a KRAS mutation? Or how do we know if those drugs would actually be applicable to to RASopathies patients? So is it possible to learn from protein structure data or different drug discovery platforms whether oncology candidate drugs will be applicable to mutations in other RAS isoforms or other proteins in the RAS pathway?
Thank you, Beth. I think we might have maybe one or two people in the process of submitting. Can you raise your hand if you wanted to give a pitch, but just haven't finished submitting the form yet? Okay, let's take another quick 2 or 3 minute break for everyone to just think of any last ideas. Again, if you end up coming up with something after today, you still have 2 more chances, but those will definitely be smaller audiences and later in the event. So we encourage you to get them out now. It's okay if they're not worded perfectly or anything. Yeah. Also, we did get to 25. That makes me happy.
Oh, Jess, can you remind everybody about, even if they don't pitch a problem, they can still work on that, and that only public pitched problems, so those that are not made publicly, will be available in the forum, right?
Yes, yeah. So I think you said it pretty well. If you come up with a problem you want to work on, but you can't make it to pitching them verbally, you can still work on it with a team, but we definitely encourage you to pitch them live because those will be made publicly available on the Synapse for everyone to see, and that way you can recruit diverse teammates that maybe you can't really find just by reaching out on your own. So yeah, there's definitely lots of flexibility in here. Okay, I see a few more pitches coming in. We can keep moving forward. So number 26, we have Tuesday, and on deck, we have Debbie.
Hello again. One of the recurring issues in CFC syndrome, and I know among other RASopathies as already expressed, is sleep disorders in individuals with CFC syndrome. Many parents indicating to us that oftentimes their children can, or in cases, their children can stay awake for 24 to 48 hours without getting access to quality sleep. Many of our children participate in sleep disorder studies or sleep studies, only to find that there's no identifying cause of the sleep disorder. Our problem and our pitch would be to help us identify solutions to sleep disorder issues and potential treatment mechanisms that can better impact sleep and potential behaviors in CFC syndrome.
Thank you. Number 27, we have Debbie, and on deck is Vivica.
Yeah, so I'm Devi again. So my pitch is pretty small. So during the webinar, I heard from one of the mentors that feeding is one of our major issues in RASopathies because of some physical deformities. The children are it's hard to feed these children, and because of that, they may fall into malnutrition. So the problem which I'm proposing is to, propose a particular device or some sort of a seating device, which can better help these people to feed their children without any, a lot of, issues. Yeah, thanks.
Okay, thank you. All right, number 28 is Vivica, and on deck is Lucy.
Hi, so this is Dr. Santosh, who is a pediatrician, and so RASopathies as a whole is common, but when you take individual disorders, it is rare. So me being a pediatrician, my thoughts go into how can we antenatally diagnose or antenatally look into this. So what are the various methods? If the methods are available, how do you economically make it available to the lay population or the non-affordable state, first affordable and then come down to the poor individuals? So is there a way we can work about antenatally diagnosing RASopathies? And I wish to look into this problem. Thank you.
Thank you. Okay, number 29 is Lucy, and on deck is Beth.
Hi, Lucy. Rare disease patients wait on average 7+ years in the US for a diagnosis, and in 40% of those cases, patients often receive a misdiagnosis. This process is flawed and it's unfair to those with rare diseases as they are often excluded from the traditional healthcare system. So hypothetically, how could we use medical data to improve this process? Like, for instance, inputting symptoms, birth, gender, residence, traveling, genetic exams. So kind of like a 23andMe, but for rare diseases. And then how can we quantitatively track medical data with real world data, electronic health records, claims, and billing activities, and use data to improve this process for those with rare diseases? Thank you.
Thank you. All right, number 30, we have Beth, and on deck, Colin Stone.
Oh, okay. So if Colin may be wanting to pitch this, but
yeah, I'm here.
Okay, let Colin go first. And if
sorry.
Go ahead.
One of the problems, particularly with Costello syndrome, is major issues with feeding and particularly weight gain. It seems that our kids with Costello need significantly more calories than an average infant of their age and weight. Because of that, it is almost impossible to get the dietary needs sorted, especially when moving on to blended diet or oral feeding. Some way to get to something like a reverse Weight Watchers app or technology so you can work out calories and other nutritional requirements quickly and easily would be incredibly helpful for parents rather than reading individual labels laboriously.
Thank you. Beth, did you have a problem pitch as well?
Yeah, so I was going to raise a similar issue. Thank you, Colin. About many retinopathies, kids have this lean phenotype, so their body type is, skinny and small. We don't know really what the reason is behind that, why they don't seem to gain much weight despite having a high calorie intake. So what the pitch is basically, how can we find more information about the metabolism of individuals with retinopathies, both at the body systems level and the cellular level? Is there any information out there?
Thank you, Beth. For 32, we have Tuesday.
Hi, this is Betsy. Tuesday typed it in for me because I'm having, I think, the same challenge. But I was thinking about exactly the same thing that Debbie Krishna, I think, was talking about in terms of how we deliver services to people who are undiagnosed. We think that most of the people who are living with CFC syndrome probably don't have a diagnosis yet. And so how do we use our existing data to focus diagnosis efforts and support them? Thanks.
Thank you, Betsy. All right, 33, we have Yuja.
Hey, I believe my team has already pitched once, but I have a different idea. So I remember one of the problem statement on the website says that a lot of patients who suffered from retinopathies experience pains. I did some research on how prevalent that is, and I believe an official report have documented a year-long investigation on how a lot of patients, no matter what kind of retinopathies you're suffering from, is having that painful experience. So my approach is I would like to study the molecular mechanism behind pains, whether it be looking for the protein-protein interaction network of pain mechanism and retinopathies, although I doubt that could work, but that's one idea I have. Thank you.
Thank you. Okay, let's see if we have any. That looks like that's all the submissions we have. I'm very impressed with the number we have. That's like almost 30 or 50% of the number of participants. So really awesome. Thank you everyone for getting up and pitching your problems. So real quick before everyone runs off, I just want to give a preview of what's about to happen next, so we're all on the same page. Okay, so yes, today's pitch recordings are all going to be available on Synapse soon. We will also be releasing a spreadsheet of all the pitch numbers, the person who submitted it, and a quick summary of each pitch. You're going to want to talk with other participants by searching for the correct Slack channel. So if you're interested in pitch number 1, you would search for pitch_001. And same thing all the way to 33 is what we have now. And we really encourage you to talk to people with different backgrounds than you. As we've seen over the years, the strongest teams have members that span many different areas of expertise. Then you're going to want to form teams of 2 to 6 people around an unmet need that you all identify. Then you want to officially register your team on Synapse and fill out 1 team registration form per team. We encourage you to try to do this soon so you can all get hacking and into just working together. But the final deadline is on July 16th, so you do have some time. And also for some further clarifications, I mentioned this earlier, but as a reminder, if more than 6 people want to work on an unmet need, Definitely, we encourage you to split into smaller teams, as 6 is the maximum number of people on a team as well. You can work on similar solutions, or maybe your solutions will go in completely different ways, and that's what makes it really cool. And also, again, if there's on the reverse, if there's multiple pitches that seem similar and you want to combine them, you can definitely talk about that as well. So yeah, does anyone have any last questions about the process that we can answer? All right, looks like we should be good. I think Salvo, you have a couple last minute or a couple closing statements for us.
Yeah, and just a reminder that we'll have next Friday, we'll reserve 15 minutes or so for other ideas, late comers or late breaking abstracts, if you want. So next Friday and the Friday after, we really encourage you to use next Friday, as it will give you more time to work and create that team on that pitch. But I just want to share my slides. So if you can stop yours, Jessica, I will go and take it from where I left, which is here. So first of all, I'm super impressed by the quality of the pitches and the idea, and it's really, really exciting. One thing that I want to point your attention is the attendee guide. So a lot of questions that I get are answered in the attendee guide that you can find on the Hack4Rare website. Just go through the different section, you'll find a lot of the mechanism that we just talked, and a lot of answers about how things works for the organization. The other tab that I want to point you to is the data section here in the middle, but you can also find the truck page also have more specific data for that specific truck. So make sure that you explore this. There are a lot of links. There are a lot of informations and things you can use to broaden or go deeper into your solution. And as a sneak peek for next Friday, as you know, we're gonna have now the hackathon open for 5 weeks, so that you have plenty of time to get your team, identify your problem, get your team, and do all the things you need to do to get to file submission on July 30th. So that we'll keep you company, and we hope you'll join us for a weekly check-in on every Friday. So the first one is on July 2nd at 12 p.m. We'll have our first weekly check-in, number 1, and we'll have guest speakers. So next week, we're gonna have Alex Joyner from Varsom. He will talk about how to use the Varsom API and how to use this as a resource tool for your project. And we also have a speaker from Children's Brain Tumor Network that will specifically talk about the OpenPBTA tumor data set. This is a data set very well organized, very well harmonized data set that contains thousands of tumors, genomic data, and more. So someone from the Children's Brain Tumor Network will talk about this a little bit more. Then we'll also have problem pitching, as I said, and more surprises for you. So thank you so much for joining us, and keep submitting those ideas if you have, and let's keep the conversation going on the Slack channel. And yeah, Julia, go ahead.
I had a question from Lars asking for the Slack channel URL.
Right, yes, so I will post it right now. I just need to get out from my presentation. So there is a button on the main page of Hack4Rare, which says after registered to the 2021 Hack4Rare, there is a new join the Slack channel. That should already work. I can't.
Salvo, I have the Slack channel open. Shall I just put it in there?
Yes. So this is the main, if you go on this main page, then you can join the Slack channel just clicking on the second button that says join the Slack channel. Anything else? Any other questions? About today, or any other remarks from anyone else? Anyone of the organizers? Okay, so that's all. Thank you for joining us. It was awesome. And stay tuned, and we'll post all of these awesome questions in the Hack4Rare. So there will be an announcement also where these are on the Slack channel. Thank you for joining us. Have a great weekend.
Great job. Thank you.
Great job.
Thank you.
Thanks, everyone.